Welcome to Module 6. This is the second video for this module, 6.2. And in this module, we are going to look at how to solve word problems. This is going to be a little bit of a review from modules 1 and 2, and I recommend you go back to look at some of those for some of the instruction, because it's going to be a little bit more than what's going to be in this module. So this is another way to look at how to solve word problems with the same basic premise of how to translate English phrases and sentences into algebraic expressions. And again, pull out your translation sheet that is in the materials section of the Blackboard course shell if you'd like to be able to see some of the words that we use in the translation process. So in translating English to algebra, again, we're just going to be looking for words and phrases and transfer those into mathematical expressions or equations. And we're going to look at and use certain signal words, and you'll see them over and over again. Here's some right that have been listed by your book by Pearson, and again, go back and look and see in the materials section for that brightly colored sheet that has some more. Here's some more signal words that you can use. I do want you to take note and be careful that specifically for this, and you'll see this oftentimes, and it tends to throw students. There's a phrase that's 8 less 5. Remember, that means 8 minus 5. And so that's different than the term 8 less than 5, which means 5 minus 8. So look at those, kind of jot them down on the side of that other sheet if you need to or somewhere. But remember that this is this is two phrases that I see oftentimes confuse students. So 8 less 5 is different than 8 less than 5. Well, let's take a look at an example. And so again, this is math for the trades, and so we want to put this into some relevant word problems. So we're going to look at the simple phrase, the height of the duct is equal to its width. And so remember, simple translation, we don't know the height of the duct, so that we can just put as a variable. In this case, we'll use capital H. Is equal to is very specific to equal, and that's the mathematical operation, and its width. And again, it's not saying what it is, so we'll just go ahead and call it a variable. In this case, we'll use W. Now, let's look at a way to be able to do this on a longer word problem. And so when we're looking at this word problem, remember, one of the first things I want you to do is to read the problem through and just read it through. Then go back and read it again for context, and then read it again until you really understand what it's looking for. So if you'd like to pause the video right now to be able to read this problem and then come back to it, then please go ahead. Okay, we're back, so let's go ahead and look at what this is really saying. This is saying the electrical resistance of a length of wire is equal to the resistivity of the metal times the length of the wire divided by the square of the wire diameter. All right, well, let's see. Let's get rid of everything that we don't need in this that is not having to do with some of the key words that we're going to use for the math problem. And so we're going to say, all right, the resistance, because that's going to end up being a variable, and yeah, it's wire, but that's not as important, is equal to resistivity, whatever that is. That's something that's another variable. It doesn't matter what it's resisted to. Times, so that's an operation. The length, in this case, this is a measure, divided by square, which, remember, square actually means something in this, and we covered that in chapter 2. And and the square of the diameter. And so we can say our word equation is going to be the resistance is equal to the resistivity times the length divided by the square of diameter. And putting that into a actual problem, then what we can do is we can just substitute the letters and the symbols for what we had for the words. And so you can see that resistance here is equal to, and then it says resistivity, which is a variable, times the length, which is another variable, and then divided by the square of the diameter, which is d squared. And so now we have a formula that we can start to work with the problem and substitute in numbers for that. Sorry about that. So let's look at an example, and this says, so go ahead and read it and pause the video, come back when you're ready. Okay, so this says that a total of 66 cubic yards of concrete is required for a pour. This is something that's going to happen on a job site. The combined amounts of cement, sand, and gravel, so it looks like some variables, should be 1.5 times the amount of concrete that's needed. For this particular job, cement, sand, and gravel must be combined into a ratio of 1 to 2 to 3. What's the volume of each component that will be necessary? So to take this on, let's go ahead and look at what we have here. So first off, we know that the amount is going to be 1.5 times 66 cubic yards of concrete. So that's what we're looking for. That's the amount that we're looking for. So 1.5 times 66 cubic yards. And so that amount will end up being, okay, let's go to a calculator. And that's going to be 99 cubic yards. Okay, so now let's go ahead and try to figure out then what we're looking for. Let me get the calculator out of the way here. And it says that for this job, it's cement, sand, and gravel. And they're going to be combined in a ratio 1 to 2 to 3, and I'm just going to go ahead and color code these. So cement, sand, and gravel. So maybe you can kind of start to envision this a little bit. And this is something you can do to help you if you'd like to. If you have different colored pencils, sometimes that's helpful. So what volume of each component of the 99 cubic yards is going to be cement, sand, and gravel? Well, we can write this, and one of the things that we can do is we can say, well, okay, we know then that cement is only one part of it, right? So we can say X will be cement, and sand is going to be two parts sand, so it's going to be twice as much as cement, so sand will be 2X, and the same thing for gravel. There's going to be 3 times the amount of gravel, and so we can say that gravel is 3 times. Okay, now all of those combined, and I'm just going to go ahead and do this in black for all of them, X plus 2X plus 3X are going to be 99 square yards. So now that you've got that information, then what we can do is go ahead then and we will just add those up using, and we'll combine our like terms. So X plus 2X is 3X plus 3X is 6X equals 99. And we can go ahead then and calculate what X is going to be by dividing 6 off of that and isolating our variable. And so let's go ahead and get the calculator. 6 is 16 and a half. So x equals 16 and a half cubic yards, which is going to be part of the answer to the problem. So let's come back over here and see what we've got. So we had said that X was cement, and it's going to be 16 and a half cubic yards. Well, now sand is 2x, so if it's 2x, then we'll just take 16 and a half and multiply that by 2, which is 33. And so we'll end up with 33. And then we said that gravel was 3 times the amount, and we can just either multiply that times 3, 16 and a half times 3, or add 16 and a half to 33 and come up with 49.5. And if you add all of those up, 16 and a half, 33, and 49.5, you should come out to 99 yards square, and you have the answer to the original question, which is what was the volume of each component. So hopefully that is another method to be able to help you in some of these more complicated word problems. Let's go ahead and go to one more problem, and we're going to look and suppose that an auto mechanic has collected $1,468.63 for parts, including 6% tax. So for accounting purposes, he's got to figure out how much of the total tax, or excuse me, how much exactly of the total is sales tax. So to be able to do this, we want to be able to pull off the amount for tax. Wait a second, I'm trying to get my icon back over here. Okay, now I've got my little drawing tool again, and so we want to be able to look and see then how much the whole thing costs, including the tax. So we know that it costs a certain amount, let's say X, and we know that, and it says that 6% of the original amount was taxed. And so we can say, okay, we don't know what the original amount was, that was X, but 0.06 times X was going to be the tax. And the whole thing ends up being $1,468.63. So now we can go ahead and add these. Now when we add these, be really careful to remember that this X over here is actually 1x. And so what we've got here is we've got 1.06x equals the total sales amount. And now it's just plug and chug. Make sure you remember to, what you do to one side, you have to do to the other. We'll take our total amount, 1,468.30. Oh, excuse me. 0.63 divided by 1.06 equals 1,300 equals $1,385.50. And so now we know what the original amount was. Let's go back to the question, and the original question says how much was the total is tax. So make sure you always go back to answer the problems you do. So then what we'll do is look at the amount that was originally paid, and that was $1,468.63. That was with the tax, and we will subtract the amount for the parts. Now let's go ahead and just do this, and it's through. So when we look at the overall amount paid for tax, which was the question, it's $83.13. And this will conclude this video for this module.